Hello, in this video we will explain to you about the addressing mode. What is meant by addressing mode? Different ways of specifying the address of the operand is termed as an addressing mode. Depending upon where the data is, the address is to be specified. The data may be in one of the CPU registers, memory, or input port. So, one of the addressing mode is immediate addressing mode. This mode is used to access the constant. The data that is present is in the address field of the instruction. So this is the instruction design for the immediate addressing mode. We will have the opcode and operand. The data is directly stored in here, which is in operand. The design like one address instruction format. The operand is a part of the instruction. The operand is also the address field. Immediate addressing mode usually denote with symbol hash. So this is the example. Add R0 hash symbol 23, which means add 23 into the register R0. So this is the first source and this is the second source. This is actually the plus. So it is given some constant to be added into the R0, the register 0. So this is immediate data, immediate addressing mode, and this is the register addressing mode. So please take note that immediate addressing mode is always used as only source address, which is mean that this 23 cannot be the destination. It only can be used as the source address. Here is another example of immediate mode. Move a hash symbol 6A hash, which is move the data 6A hexadecimal into accumulator. This picture describes the above instruction and execution. The opcode for move a hash data is 74 hash. The opcode is saved in the memory 0202 address. The 6A hexadecimal is saved in the program memory 0203. This is actually we can use any part of the program memory, and this is the example that we choose, which is 0203. When the opcode 74 hash is read, the next step taken would be to transfer whatever data in the next program memory address, which is here is 0203, to the accumulator, which is accumulator A. And then E0 hash is the address for the accumulator. The instruction is of 2 bytes and 1 cycle. So after the execution of this instruction, program counter will add 2 and move to 0204 of the program memory. The hash symbol before 6A indicates that the operand is a data of 8-bit. If hash symbol is not present, then the hexadecimal number will be taken as an address. So the advantages of immediate addressing mode is no memory reference to fetch data, and the immediate addressing mode is fast compared to other addressing mode. But the disadvantage of this mode, it is the limitation in immediate addressing mode is that the range of the constant are restricted by the size of address field, which is mean that it is not flexible enough to be used.
Next, we will talk about direct or absolute addressing mode. Direct addressing mode is used to access the static variables. An example of static variables is integer a, b. In this mode, the data is in the RAM memory location whose address is known, and this address is given as a part of the instruction. In other words, direct addressing mode accesses the data in the memory with address. For example, move A 01F hexadecimal. Now, we will take a look at the diagram of direct addressing mode. In the instruction, it will contain opcode and address A, and next the memory will have operand. In address A, the address field contains the address of the operand. For direct addressing mode, the effective address is the same as address field value, which is also the same as memory address. In case you didn't know, effective address is the address where your data is present. We will take a look at this a little closer in the next example. For this example, we will take a look at the instruction add A 2000, which means that it will go to the address 2000, which in this case we assume that it contains 20, and then the data in the memory will be added to the accumulator, which we will assume will contain 5, and then the result of these two together, which is 25, will be added in the accumulator. Instead of 5, it will be replaced with 25. The advantages of direct addressing mode is first, it is simple compared to the other addressing mode. Next, it is only using a single memory reference to access data. And lastly, it has no additional calculation to work out the effective address. The disadvantages of this addressing mode is that it has limited address space, which means that the size of address field is fixed and it is not flexible.
Now we will discuss about indirect addressing mode. This mode is used to implement the pointers. The instructions give an address which contains the address of the required operand. So there are two types of indirect addressing mode. There are memory indirect, there are register indirect. We will talk about the advantages and disadvantages of indirect addressing mode. The advantages is it requires large address space, and the disadvantages, the instruction executions requires at least 2 memory references to fetch the operand. We will see the advantages and disadvantages in the following examples. So this is the indirect addressing diagram. We have an opcode and the address. So how the indirect addressing works is the address will now point to the address. This address will point to the data of the operand. Now we will look at an example for memory indirect. Load RI 2000. The curly bracket shows that this is an indirect addressing mode. So we will look at the diagram below. So in this memory 2000, it will contain 200. This is not the data of the operand. This is a memory. This memory will show that there is the data operand of 20. So then this 20 will now load into RI. So don't get confused if you see an alias symbol. This alias symbol will also show that this is an indirect addressing mode. It is the same as the curly bracket. So indirect addressing mode can only be cascaded by using multiple levels. We will see that in the next example. Now we will see an example of a cascaded indirect addressing mode. So load RI to curly bracket 2000. So it is quite difficult to say this in words. Let's see the diagram below. In the memory address of 2000, there is 200, which is also a memory address. In the memory address of 200, there is 20. This 20 is not the data of the operand as the previous example. The 20 is a memory address. It will show inside the 20 now is the data of the operand 2. The 2 we now load to Ri. So we have done on memory indirect. Now we will go to register indirect. It is similar to memory indirect, but there are a few changes. So load Ri curly bracket B. B is a register. The previous one is a memory. So the register specified within the curved bracket specifies the register containing the address of memory location containing the operand to be loaded into the register Ri. So the B is a register. Inside the B there is a memory address of 200. Inside the memory address of 200 there is 20. The 20 is a data operand which be loaded into the Ri. Okay, that's all for us. Thank you.